Good morning, everybody. I'm Christian Dickman. I'm one of the architects in the vSAN team. Christos, who's co-speaker, is currently not here yet. He seems to have a conflict this morning. He's our overall storage architect and one of the tech leads in the vSAN team. And I hope that you got a chance to attend his session either yesterday or on Tuesday about the architecture of vSAN, what it is, and all of that stuff. That was a great session. If you did not catch that session, definitely take a look at the recording. It had a lot of really, really good content that I won't be able to cover today. So let's start with this one. Please read the disclaimer while answering a few survey questions. Who of you knows what vSAN is? All right, that's good. You're in the right session then. Who of you has used vSAN? All right. Who of you had trouble that you needed to shoot with vSAN? You don't count, Hungan. All right, so hopefully this session will give you a little bit of help, either if you already had some trouble with vSAN or if you think about having some trouble in the future. So briefly before I get into the talk, I wanted to level set what this talk is and what it is not. I don't have the time to go over what is vSAN in depth. I also won't have the time to essentially do a user's manual where we go through every single troubleshooting tool one by one, every single command that we have one by one, and give you the exact usage. All of that I won't be able to do. But what I thought would be useful to do at this venue is to walk you through a set of 5 concrete troubleshooting workflows. 5 things that we see every customer going through, either during initial deployment or later during the actual production phase of vSAN. And I tried to compose them as a checklist, a run book to run through, to combine all the different tools that we have to try to figure out what's wrong with the situation, how to analyze it, how to understand it, and how to remediate it. The tools that we use here are the usual. First of all, the vSphere Web Client. That's where most of it happens. In addition, the Ruby vSphere Console, RVC, where we've added a whole bunch of interesting commands to use for vSAN. The vSAN Observer, that's part of RVC, that allows you to do performance monitoring and troubleshooting. And then the ESX shell, or as William corrected me, the ESXi shell, with ESX CLI, ping, all these kind of commands that you use on the ESX shell. All right, I have one slide on what is vSAN. If you really don't know what it is, take a look at this slide. What we do is, it's all in software, built into ESX, a storage solution. It aggregates all your local flash, your local magnetic disks, into one shared data store with the primary focus on providing VM storage. It's converged compute and storage in the sense that the same servers that you use to run your compute are also used to provide the storage for those VMs that are running on the hosts. It's distributed in the sense that you have a whole cluster of hosts, in fact the vSphere cluster of hosts, all in a distributed fashion joining together to provide the storage for all the VMs running in that cluster. There's no single point of failure in that architecture, and that's one of the really key aspects of making this an enterprise-grade storage system. We are also deeply integrated with the vSphere stack from the kernel, where we preserve all the CPU cycles, and Christos talked a lot about that in the architecture, to things like HA integration, where traditional VSA solutions had problems. We did a lot of work there to do a deep integration, all the way to the APIs and the UIs and the UI workflows, the management workflows around upgrades and all of that stuff. We are deeply integrated, and that is really what makes vSAN simple. That's what makes vSAN resilient, and that's what ultimately makes it a great product. All right, so before we get into the troubleshooting workflows, a few words on RVC, because you've probably seen the vSphere Web Client. You might have not liked the performance of it, but you do know about it. But you might have not heard about RVC. So what RVC is, it actually started as a VMware fling, which is a way for us to experiment with new features, experimental features that we think might be useful to you. And it's an interactive command line, RVC, where we put in a whole bunch of vSAN commands for useful troubleshooting. And people found it so useful, actually, internally and externally, that we decided to ship it in box. So with vSphere 5.5, both for Windows VC as well as Linux VC, it's actually part of the distribution. And we're still, even though 5.5 has been out in the wild and update 1 has been out and vSAN has been GA, make sure to pick up the latest versions because we're still extending and improving RVC in the 5.5 train of releases. In terms of deployment, we suggest, while you can just use the VC that you already have to run your vSphere cluster, you can start RVC in there. If you run it in production, we recommend to take another VC appliance and use it as an RVC appliance. You don't actually need to turn on VC. It's just a way to get access to RVC. On the slide, I have the little steps to actually start RVC. You just log in through SSH, you start RVC, point it at the VC you want, and you start going. I won't go into the details of that, but you have it on the slides. The slides will be available for download, so anything I have here, just go back to it later. So what did we try to do with RVC? It's really, from a vSAN perspective, we covered every single aspect of what you will need to do with vSAN, from configuration of vSAN itself and the storage policies, to things like monitoring, troubleshooting, to performance monitoring with the vSAN observer. In terms of how does RVC compare to other tools? Well, first of all, the vSphere Web Client. The vSphere Web Client is what we want you to use on a day-to-day basis. It's easy. It has all the nice UIs, all the nice interactions, but compared, RVC has more details. And we will see how we can use some of these pieces of information during the troubleshooting. If you compare it to ESX CLI, however, the key benefit that RVC brings to the table is to have the whole cluster view, or even the whole virtual center view of your inventory. ESX CLI only knows about a single host, and with vSAN being distributed, a single host doesn't tell you the full picture. So RVC, talking to Virtual Center, can tell you the full picture, and that's one of the key benefits. It also has all kinds of cool features like mass operations, doing operations on thousands of VMs at a time with a single command line, all of those kind of interesting things. One of the other aspects of RVC is that we, in the vSAN team, actually use it as a way of experimenting with features. So, for example, during the beta and then with GA, we introduced a command called the Resync Dashboard. That command tells you all about background activities, syncing that vSAN does in the background, which wasn't part of the UI and wasn't part of any of the tools that we originally had when the beta went public. But then we introduced this tool. We heard from a lot of you that this was really useful and you liked it. So actually, if you pick up the beta of vSAN 2.0 that's currently out, and you can all sign up for it and try it out, you will actually see that this feature made it into the UI based on this feedback. So there's a bunch of other things that are in RVC today that are not in the UI. If you like them, do let us know, because those will be the first ones we will integrate into the UI going forward. All right. So with that, I want to jump into the 5 scenarios that I want to talk to you about. And they're roughly aligned with how you would actually experiment with vSAN. It goes from starting to use vSAN and trying to verify that you're actually using supported hardware, to trying to set up your network, figuring out if vSAN shows you that you have a misconfiguration, how to debug that. Then later you're in production, something goes wrong. A VM is marked as non-compliant, inaccessible, even orphaned. How do you deal with that? Or maybe initially or later, VM provisioning starts failing, and you're trying to debug why that is and how to deal with that. And then finally, basically everybody through, while you're evaluating vSAN, you're bound to do a vSAN benchmark. And I'm going to show you how to use the observer to actually understand that. How do you figure out what the benchmark is telling you, where the bottlenecks are, and so on. And so these 5 troubleshooting workflows we see as what everybody goes through in the lifetime of vSAN. All right, so let's jump in. The first one is really verifying that you have supported hardware. And at this point, I have to stress this really, really hard. You have to use supported hardware. Last year, we said this. Last year, when we were in public beta, we said supported hardware will be important, but we didn't actually know quite why, because we had bought hardware, it had all worked, and then you guys came and tried out all kinds of hardware, and actually found found, I recently read a statistic from our support team that the majority of all support cases that we had were about troubling hardware. So vSAN worked actually quite well for everybody who tried it. However, if you tried it on unsupported hardware, you might have not had the best of times. So definitely make sure that this is the first step that you do before taking a cluster into production. All right, so actually when it comes to the hardware compatibility list, two things apply. First of all, the vSphere compatibility guide, which is your servers, your NICs, and all those standard components that have nothing to do with vSAN directly. And then the vSAN specific compatibility guide. Most important, the RAID controller. We saw a lot of problems with RAID controllers and in general I/O controllers, so definitely take a look at that aspect. And then to a lesser degree, SSDs and magnetic disks that are really important as well. So 3 simple steps. Collect your hardware information, verify it against the portal, but then also verify your drivers, and I will get into why that's important. All right, so how do you figure out your hardware? In RVC, there's a nice command called the vSAN disks info, and it tells you basically everything you need to know. You have a screenshot here. It tells you the model number of your drives, the type of the drive. It tells you the driver name, MPT2 SAS. It tells you the name of the device. You can also derive the same thing on ESX with various commands, and you already see there's more commands to get the same information, so RVC is useful here. But one thing that RVC doesn't have that is on ESX is finding the PCI IDs, and I will get into why that's important. So there's, if you do the PCI list command, you will find the device IDs, and that's relevant, and also the driver version number is quite relevant. So quick screenshot, specifically the vendor ID, the device ID, and the driver version number that you will see with those commands. So how do you use that information? Well, you go to the vSphere portal, and you can either Google for it, or you can go to our website and click a few links. But thanks to Duncan, we actually have this real nice little URL that you can go to. The SSD, very easy. You have your model number, you put it in, you get the result. Nice and easy. I did that with the controller, and it said nothing found. And then I was like, do we run unsupported hardware ourselves? Are we that foolish? And it turns out, no. We were actually running supported hardware, but it still didn't show up in our portal. So here, I'm trying to tell you why, because the device was actually renamed by the vendor since it had originally been built and shipped. So the device showed up under one name, but the portal had it under a different name. And that's actually a key now, that you need to use the vendor ID in those cases, the device ID and the sub-vendor ID and sub-device ID to find exactly the device that you have. I did that, and indeed the controller was on the supported list, and it was under this new name from LSI. So with that, it's still relatively easy to find, but this was a gotcha that I ran into trying to prepare for this presentation. So then, step 3, your driver. And that's actually another thing that's quite important to put into your operational procedures, because it's not just something you should do at the beginning, it's actually something that you should do on a regular basis. Because what we do is for every release of vSAN or of vSphere, and for every device, for every controller, we actually recommend which driver to use. Sometimes we recommend the inbox driver that came with the release. Sometimes we recommend a particular version of an async release that the vendor provided. And that's actually changing over time. As we find issues and as we work with the vendors to resolve those issues, we update the recommendation for the driver. And the driver plays a critical role in both reliability and performance of your vSAN. So you do want to make sure that on a regular basis you go back to the HCL, you check that you actually are still running the right driver, and that you update your driver to those versions when necessary. In a similar way, we also have firmware versions on there, I believe. And make sure that you don't just upgrade your firmware on the controllers, because we've seen that certain firmware updates change, for example, the queue depth, and that causes problems. So do check out the firmware version as well. Quick screenshot of how the portal looks like. On the top, we have the SSD, and on the bottom, we have the controller. A few interesting pieces here. For the SSD, it's not just important to look at the SSD from a support perspective, it's actually important to look at which performance it gives. Because people frequently ask us, how fast is vSAN? And well, it's software. It doesn't have any speed. It's as fast as the hardware that you give it. So you should definitely check out, and we try to provide a class to give you a rough idea into which class this SSD falls and what performance to expect. And then for the controller, I have the device IDs because that was important in the driver version and name. All right, so you have supported hardware. You've done that. You're not trying to deploy vSAN and actually get it up and running. And you might go to this page, central page in the UI to get the vSAN status, and it will tell you misconfiguration detected. And that's great. You know that you have a problem, and it's great because it doesn't tell you anything about what the problem is. We like creating UIs like that. So how do we figure out what's actually happening here? And before we do that, let me remind you what the requirements are for vSAN on the networking side. We do recommend 10G, can be shared. We don't recommend it, but it is supported to use 1G as well. For 1G, we do ask for it to be dedicated to vSAN. We're asking for a single layer 2 network among all the SX hosts, not because we can't support layer 3, but more because it makes it much easier to think about bandwidth, latency, multicast, those requirements that vSAN has. And that's the third item. IP multicast is a key feature that we need in the network for vSAN to work. All right, so how do we figure out what vSAN saw? What was behind that little misconfiguration detected? How do we figure that out? On ESX, we have a command to get the status, but we need to run it on every single ESX host. On RVC, we have one command that we can just run, and it tells us the information about the whole cluster. That's much more convenient. We also have a command that's quite useful. If you have a switch that's not Cisco, you will have LLDP that you can enable, and there's a little command here that collects all the information from LLDP, and it will actually tell you exactly which uplink is linked to which physical switch and which physical switch port. And that's quite useful, and it's actually working here even without creating a DVS, even without actually connecting the uplinks. So this is quite useful. The situation that I want to talk to you about in the troubleshooting here is this. We have two switches. One host is attached to one switch. The other two hosts are attached to the other switch, and the switches are interconnected. So keep that topology in mind when we start to go through our troubleshooting workflow. So this is how it will look like. This is the RVC output for the first two hosts for the cluster info. You see a few things like vSAN elected a master, it elected a backup. It actually elected two masters here because that's our problem. We have the cluster UUID, node UUID, but the really important thing is where the blue arrows are, the member UUIDs. What we see here is that one host thinks he's all by himself, and the other two hosts think that they are forming a 2-node cluster, but we actually try to form a 3-node cluster. So why is that? And you see that on ESXCLI you have the same kind of information, but you need to run it on every single host. So it's a little less convenient. So how do we debug this? And here's a runbook. Just run through the checklist, figure it out. First, make sure that every single ESX host has a VMKNIC configured for vSAN. I have the links here. Ensure that the VMKNICs are on the right IP subnet. Well, we ask for an L2. Make sure that you're actually on the same L2. Make sure that you have your VLANs configured. So if you have done all the basic checks and made sure that you've actually configured all the things, now actually do a ping check. Log in, go from each host to each other host and run a ping. That makes sure that unicast connectivity is there. I actually recommend to run that with a packet size of 9,000. Because if you have MTUs configured and if you have it misconfigured, putting it as a 9,000 ping will actually find that issue and tell you about it, while doing a ping with a small packet size will not tell you any MTU issues that you had. So then that's the next issue. Make sure that you have your MTUs configured correctly. One quick shout out, because a lot of people asked, we will publish a white paper on networking, and we will basically tell you all about why jumbo frames is something we don't strongly recommend, because there's no big benefits to be had from jumbo frames. So short story, don't bother with MTUs, but if you do these checks. And then there's a command to actually check on the multicast settings for vSAN, because vSAN uses particular multicast IP addresses that you can change, but we use some defaults and port numbers, and you will find them here. So in RVC, again, we can check the VM KNX. We can see that which ones they are configured, what their IP addresses are, and we can check our configuration and have a quick view that everything is correct. Same for the UI. We can list the VM KNX, get the IP addresses, get the traffic types, all that stuff. Great. On ESX CLI, we can get the MTU sizes for the VM KNX and the switch. You need to get both right. And then the vSAN network information where we get the multicast IP addresses and the port numbers. We will use that in the next step because let's assume in this situation we've actually done all these steps. We have the VM KNX, we have them in the right subnet, we've done the pings, everything looks good. What's the problem? Well, if all that works, probably it's IP multicast. That's the problem, that the one additional requirement that vSAN has, and that's probably the problem. Now, most likely, do we have any network admins in the room? I'm going to make fun of you guys, sorry. So, in basically all the cases that I've seen, it's not ESX's fault, it's the network admin's fault. So, what this guide is going to say is how to prove to your network admin that he's at fault. And literally every single one, it was the network admin. Anyway, so what do? You run TCP dump. You've probably done that before. You can do it on ESX. You put it on the particular VM KNX, and you filter on the port number, on the UDP port number that vSAN uses for multicast. What you will see is that vSAN sends a heartbeat, a master heartbeat, every second. That heartbeat should be seen by every other host. If it's not seen, you have a network problem. So in this case, the host sees its own heartbeat, but it doesn't see the heartbeat of the other host that's also claiming to be a master, so we clearly have a networking problem. Now, the network admin will come back and tell you, no. The problem is really ESX. ESX is not doing multicast correctly. So then you run the second command to actually get the IGMP output, and you will see that vSAN is correctly sending IGMP multicast reports, and which are the equivalent of a join, and we'll send them roughly every 90 to 300 seconds, even if there's no query on the network. So we will send them, and at that point, you have proof for the network admin that vSAN is doing everything correctly. We are sending the heartbeats, but they're not being received, and the network admin can go and actually debug using the vendor tools on the physical switch side what's actually happening. In this situation, the two switches were configured to do multicast within themselves, but were not configured to actually do multicast across the uplink between them. We've seen that quite a few times in our own labs happening. All right, so at this point, we have vSAN up and running. We've been running for a few months. One morning, you come into the office, you look at your cluster, and it looks like this. VMs might be marked as non-compliant or even inaccessible. In this case, they're marked inaccessible. Even worse, my VM got renamed to this really ugly name. And I did this for the demo. It happened for the demo. And this can happen. Good news is it will resolve itself once we fix the underlying problem. So these VMs are marked inaccessible. So let's talk a little bit about what these different terms mean. Non-compliant is the new thing that you will see with vSAN and storage policies. What it means is that we don't meet all the policy requirements, okay? But that's pretty broad. That could mean anything from we are down one mirror, but we are still accessible, to we are actually down because we've suffered a severe failure, all mirrors are down, all mirrors are down and we can't access the data. Both of them could be shown as non-compliant. So the next thing that you need to look at is the inaccessible flag. If the VM is marked inaccessible, it really means we are currently down and we're dealing with an APD situation and we need to resolve that immediately. And then there's something even worse. I don't know if you've seen that before, but that can happen on an APD even with traditional storage, that your VM gets marked orphaned. What that means is that the host has actually lost track of the VM. VC still knows about it, but the host has lost track of it. And we can resolve that as well. All right, so quick architectural aspect, when is a vSAN object accessible? Because when we need to debug inaccessibility, we need to understand when is it accessible. It's accessible when at least one RAID mirror is fully intact. One RAID, one mirror needs to be fully intact. That's the obvious requirement. You've probably all dealt with a RAID 1 before. You know that one. But the second one is probably new to a lot of you because this is the first, or this might be the first clustered network-based RAID 1 that you're dealing with. What vSAN needs is quorum, which means that the majority of components, majority meaning more than 50% of components need to be accessible and available right now. And this is where the witnesses come in. If you haven't seen witnesses or you don't quite know what they are, again, check out Chris's talk yesterday about the architectural deep dive. He showed very nicely how the witnesses are needed, and he also showed how that interacts with HA for availability and partition handling and all of that stuff. All right, so what tools do we have to analyze the situation? You can, of course, also buy Duncan's book, which will probably go into all the details. All right, so how do we do this? We have two different aspects. We want to first figure out how our VM is doing. So we want to understand the situation from the VM perspective. We can do this directly from the vSphere web client. We can get a little bit more on RVC, and in particular, RVC provides us with one command that's quite interesting. In the UI, you can click on each individual VM and you can learn about its status. But you might be running a big environment. The labs are running thousands of VMs at the same time, so you might want to actually do something different. In RVC, there's a command called check state. And we'll go through the entire inventory and find any VM that is currently having a problem of any sort with related to vSAN or related to being marked inaccessible or orphaned. So that's a neat way of just getting a big picture view of your cluster. Then the physical disks. Most likely, if you are suffering from a VM being inaccessible, it's because of the physical devices, something happening in your physical infrastructure. So again, you can go to the UI, and it has all the information about the disks, about the health, about available free disk space, and all that kind of stuff. RVC has the same information. The next thing that you might be interested in is just understanding a different perspective on exactly the same question that I asked earlier. How do we figure out the total information about the cluster? We have thousands of objects, tens of thousands of vSAN objects. How do we get a quick overview over how they are doing? And there's a neat command in RVC for summing that up as well. It's called the object status report. And it will tell you all the different kinds of objects. Are they degraded? Are they healthy? Are they unavailable? And how many of those you have? And you can learn about the UUIDs and drill in really deep there. Obviously also, whenever you have a problem, check your network. Again, the same checklist that we did for issue 2 will apply here exactly the same way. All right, so how does this look in the UI? Here, what I did for the demo is I had a 3-node cluster, and I induced a failure by simply shutting down 2 hosts. Nothing fancy, I just shut them down. And this is how it looks like. And you see that we are in the vSAN view, we are under the virtual disks, and we see all the information that we want. First of all, we see that the VM is non-compliant. But again, that doesn't tell us that much. The next thing we see is it's marked unhealthy disk unavailable. That actually tells us that the VM is currently down. The VM is currently not accessible. There's a real problem that we're dealing with, and not just something that vSAN is remediating in the background. In the bottom, we see the details. We see that the witness is absent and one copy of the data is absent, and so we can't make forward progress right now, and the object is down because of that. And we see the 2 hosts that are relevant for these two components, and we can go directly attack those 2 hosts and figure out what's wrong with them. So for the demo, I did something very simple. I just rebooted one of the hosts, brought it back up, and the picture changed to this. We're still non-compliant. Because, again, we're not meeting the policy requirements of actually having 3 hosts and being able to tolerate 1 failure. We're currently tolerating 1 failure, but we can't tolerate additional 1 failure. So we're healthy from an operational status, but we are not compliant from a compliance status. And we see that 1 copy came back, but the witness is still absent. Once we bring back the 3rd host, we go back to compliant, and we're great. If we had a 4th host, this would now automatically be remediated. But in my setup, I only have 3. All right, so in RVC, this looks a lot less pretty. But we have the same information. We have the RAID tree in the top. We see the 2 components. We see the witness. We see the status. We see the hosts. We see the disks. But we see a few more things. If you listen to the talk yesterday about this concept of the owner, the host that does all the orchestration from a vSAN perspective, all the coordination for one particular object. You see which host that is for that VM or for that object. You see things like disk usage of the individual components. You see things like the CSN, the fact that the witness is currently stale and behind. Those kind of things you will see in RVC and you will not see in the UI. Also, the object status report is shown in the bottom, where we see that we have some objects that are reduced that have, and we see them as 2 out of 3 or 10 out of 15 components and how many they are, so we get an overview over the different objects and how they are doing right now. Now, what do you do? What do you do in these kind of cases? The most important thing is that vSAN handles almost everything automatically once the physical, as long as it can. And the two things that it needs to be able to remediate is the object still needs to be accessible. The moment we've lost access, the moment we've lost quorum, we can't do anything anymore. But as long as we have quorum, as long as we have the object still accessible, vSAN will automatically remediate. We will just spin up a new copy somewhere else and move on. The other thing that we need is, well, enough resources. If we want to spin up a new copy somewhere, we need to have the resources to do that. And so that's the next step that we need to verify. So the two things that we essentially need to look, do I have this here? No, I will talk about that later. One thing that you're interested in here is you actually want to learn about that remediation. You want to see that remediation going on. You want to see when it's done. You want to see how far it is, how long it will take. And that's where this resync dashboard that I talked about earlier comes in. It shows you all that activity running in the background, what vSAN is doing, how it's remediating. In the UI, the only thing that you can do in 5.5 is actually click on any single VM, and you will see how that VM is doing, but you won't get the big picture view. And again, that's something we are adding. Now, if vSAN was not able to automatically remediate, the solution is simple. Add the resources, fix the underlying problem, bring the host back, reboot it, fix the power supply, whatever you need to do to bring the host back, to get accessibility back, and to get vSAN enough resources. And then last but not least, in my case, for the demo, my VM came back and it actually had the nice name and everything was good. And I didn't have an orphaned VM, but if that happens, and you might have even seen that with traditional storage, VMware used to claim that storage doesn't fail, and well, we all know better that it does fail, and we didn't used to handle that well, and we still have a few issues with that. Okay, in rare cases, and we fixed a lot of those with vSAN, but there are cases where VM still is marked orphaned or inaccessible, although it's actually accessible, although it's actually in good state. In that case, RVC has a tool for that. If you run the check state command with the -- refresh state parameter, it will actually go through the inventory, find those VMs, attempt to fix it, and in the vast majority of cases that we found in our internal testing where we're beating on it really hard and we were able to produce these, RVC was able to fix them. So that might be something that helps you. This is a quick screenshot of the resync dashboard, just showing a lot of VMs and a lot of VM decays currently syncing and how much data there is and how much total data is currently being synced. And you can run that, periodically. There's a parameter to automatically refresh this table every few seconds, and you can see how things are progressing. All right. We're down 3 out of 5. What have we done? We have looked at the HCL, we've looked at networking, we've looked at objects failing, VMs failing. Now, different scenario, VM provisioning is not working anymore. Maybe it never worked. Maybe it's not working right now. Both of them could happen. Now, this is probably, I was a little embarrassed about the HCL one where I couldn't find my controller. This is the second one I'm embarrassed about. And unfortunately, I need to show you the reality. This is the troubleshooting section, not the marketing one. I need to show you this. We have this wonderful error called cannot complete file creation operation. And if you played with vSAN, you might have seen that error. And it tells you exactly nothing. And if you use the C# client, that's all there is. That's all the information you will get, and it will be really frustrating. If you're using the vSphere App client, however, click on that task. Go to the task console, and in the bottom, you will see this error stack. And this error stack here actually has a very understandable error message. I used a policy here that needed 5 hosts, and I only had 3. Very clear cut, very easy to understand, easy to remediate. But if you don't see it there, you might call up support and ask what the heck is going on. So definitely make sure to know that you can go here and it will show you more information. And we had customers call us up saying there's no information, but it is there. And we are trying to fix that right now to make it more obvious. All right, so let's say that's not the case. Let's say we didn't get an error message that was right away telling us what the problem is, or it was too cryptic, you didn't quite understand it. Let's understand when VM provisioning might be failing. The first thing is obviously, is there any physical problem in the cluster right now? Do we have a networking problem? Do we have a failed disk? Do we have anything of that sort? And again, issue number 3, it has the full rundown. It tells you all about these things. Run through it. You will know. And now the second thing, are we out of resources? Because every time we create a VM, we actually need to use some resources. So this is where the 2 important resources come in. Disk space. Obviously, we need some disk space. But then something you might have not considered yet. Every time we create an object, there's 2 copies and a witness, or might even be more copies, more witnesses, more stripes. Each one of those is called a component. And we have a system limit right now. Each host can host 3,000 of these components. That number will go up, but there is a limit, and it's relevant to know. If you're deploying a really dense environment, let's say a VDI where you're packing lots of VMs, lots of virtual disks, maybe even create a lot of snapshots, you might be bumping into this limit. Most of you won't, but some of you might bump into it. The disk space is easy to look at. It's in the UI. We have the same place that we looked at for failures of disks. We also have the disk space. You can look at the whole cluster, the whole data store, but you can also look at each individual disk. Because vSAN is balancing the disk space on the different disks, you might want to look at, is any particular disk full? Is that what vSAN's problem is right now? Especially with really small clusters, if you have 3-node clusters, there might be a good reason to look here. The more disks we have, the more leeway we have, and it's less important. But then, the component limit is actually not in the UI right now. You will find it in RVC, however. There's this really neat command called check limits. And it will tell you both of these limits. It will tell you the disks, how full they are, and it will tell you how many components you are currently using. Another thing is I mentioned this 3,000 component limit. That actually only applies if you have enough RAM. If you're running a server with really small amount of RAM, for example, a little lab, a Mac Mini maybe, I heard quite a few people are interested in doing that in their labs. You might be running with 16 gig or even 8 gig. In those cases, you actually have less components, and the command will also tell you what your limit is. All right. So one thing I need to show you, because that's another thing that a lot of people have told us, where it's not in the UI, but it actually is. People go to this screen. It's under Manage, Settings, Virtual SAN, Disk Management, and they want to see if a disk is currently failed and how much disk space there is. And it makes sense. It's the disk management screen, and you created your disk groups here. It should show you this information, right? Yes, it should, but it doesn't. But don't worry. There is a place. You just need to know about it. It's under Monitor instead of Manage. Under Monitor, Virtual SAN, Physical Disk, you actually do get all the information. As is shown here, you have the free disk space. You have the healthiness. Whether anything is currently failed, it's here. You should just remember that it is there. All right, so in this scenario, I'm claiming we still don't know what's going on. And at this point, I'm recommending a different approach. We built the system, and we are trying to tell you all about what's wrong with the system. We try to do monitoring where we understand what's happening in all our different layers, and we're trying to tell you if something goes wrong. Well, the thing that might be going wrong is our monitoring system trying to tell you what's wrong. And that can happen. The best way of knowing whether something is working right now is to do the operation that you might want to do. So one simple trick, run a VM create on every single host and see if it's working. Obviously, package is a command that does this automatically for you. It creates a VM on every host, and it deletes it and tells you on which host that failed. So I ran that here in my cluster, and it told me something very interesting. It told me that it's working on 2 hosts, but it's not working on the 3rd host. And it's actually showing me, again, this error stack. And in this case, the day before I went into this host, I shut down one of our daemons, one of our user space daemons called clomd. And that's why it's failing now, because that daemon is responsible for VM creation and placement. It wasn't running. I fixed that point. I reran the command. It's now telling me all the hosts are good. You can also use this as a monitoring solution, not just during an active problem, but with all our dogfooding clusters internally, where we try vSAN ourselves, they are running this, let's say, every hour. They're running this command, check for the output of success, and if it's not successful, we alert to the administrator that has proven to be quite successful in identifying any kind of problem, because it does the real operation. All right. Now we get to the fancy stuff. This was all the basics, all the, just understanding basic accessibility, basic status. Now we have graphs. Now we have pretty pictures. So the situation that I want to show you is something that you will do early on in the life of vSAN. You will probably do a performance benchmark to see if vSAN meets your requirements. And you might have existing benchmarks, you might have existing methodologies, you might be new to storage, you read up on some blog how to do a performance evaluation, you're trying this out for the first time and you don't really know what's going on, you don't really know how to read it, so let me walk you through it. We have something called the vSAN Observer. It has way more information than you need because it was actually originally built for us. It was built for us to understand what was happening, so it literally has everything the vSAN engineering team would ever want to look at, and you have that available to you as well. So what do we have? vSAN Observer is a command that's part of RVC. You start it. At that point, it starts collecting information. Every 60 seconds, it gets the stats from ESX, accumulates them. It then opens up a web server. You point your browser to that web server, and you get access to all the different graphs that's in the tool. All right, so this scenario that I'm trying to show you, well, actually, let me go back here. So this is what you open it up, and you get the vSAN client view, which is the VMs accessing the storage. And you see this graph, the latency, and you can probably not read the numbers because they're the wrong color. But what it's showing is that the latency is between 20 to 40 milliseconds. And we actually color it red because we have a rough threshold of saying if it's above 30 milliseconds too often, it's probably not good. Maybe you have a different threshold in your organization, but 30 milliseconds is where we know we start getting into problems. All right, so we know we have a problem of some sort. Latencies are high, but why? Well, the first thing that we do is we want to rule out the network. Is it a physical disk problem? Are the devices overloaded? Or is there some problem accessing the storage devices? Or is it a network problem? Latency could be coming from either. So what we do is we go to the vSAN disks tab. Here we don't show how the host and the VM are accessing the storage. Here we see how the host is contributing storage into the cluster. What we see here is that it has the same curve. It has the same latency. It's 20 to 40 milliseconds there. So there's no networking involved here anymore. It's simply accessing the storage. It's having 20 to 40 millisecond latencies. So networking is out of the picture. Next thing you might ask, well, vSAN is hyper-converged, right? We have compute and storage on the same host. There's VMs running. They're consuming CPU. vSAN itself is consuming CPU. Maybe there's a CPU problem. Well, you can do that here too. You go to the pCPU tab and you see overall the CPUs are fine. Those graphs don't look too scary. And on the right side, you see all the so-called worldlets, the units of consumption where vSAN consumes CPU resources from ESX, from the kernel. And we see that none of them is maxed out. They could all go from 0 to 100%, and none of them is even close to 100%. So that's not the problem. So CPU is also ruled out. I didn't go to the memory tab, but we have a memory tab where you can do the same analysis and figure out, nope, it's not a memory problem. All right, so let's dive deeper. The vSAN disks deep dive. This is where we show exactly this caching that we do. The SSDs, the read cache, the write buffer, the magnetic disks, how they're all interrelated and how each latency in anywhere is happening. And it's a whole page, and I just zoomed in on the summary here. The summary sums up the latency, IOPS, and the read cache hit rate. First of all, we see that the read cache hit rate is really good, so that's probably not our problem. And more importantly, we see that the latencies are looking much better here. They are 5 to 15 milliseconds, not 20 to 40. So actually, the devices are good. The devices are doing fine. The devices are giving us good performance. They're working fine. They're giving us decent IOPS. The read cache is working well. So what is the problem? To understand what the problem is, we need to go back to the overview of the vSAN disks. And now I'm showing you a few more graphs that are on this page. And the one thing on the right that you see is the outstanding I/O. And the outstanding I/O here is 200. And now you need to understand one thing about vSAN, and it's actually a quite important and interesting aspect of vSAN, which is we have a scheduler. We have an I/O scheduler at this point in the stack, where we need to make sure that when we do rebalance, when we do resync, when we have management applications competing for the storage or multiple VMs competing for the storage, we need to make sure that they all get the right priorities. That it's not one VM sucking up everything and or the resync traffic sucking up everything. We need to be smart about this. So we have a scheduler here that does exactly that. It makes sure that we only have a few outstanding IOs to the devices, just enough to get the optimal performance from the devices, but nothing more. And then we can actually do intelligent scheduling, and we can decide which I/O should actually go to the device and which one needs to wait. And that's exactly what's happening here. So what is the root cause? The root cause of our problem here is that what I'm showing you is actually a benchmark run where we used a really old SSD. An SSD, when we started vSAN, we bought this device. It was a great device back then, but it's no longer quite that great. It's an Intel 710. If you look at the spec sheet, it says it has roughly 4,000 to 6,000 IOPS, and it achieves that at 4 outstanding IOs. Now, I have a whole presentation, or at least a section of presentation. I have a link at the end to a webinar where I explain this. The important thing for you to understand if you look at benchmarks, if you want to understand storage and if you want to understand benchmarks, these numbers that you see, latency, IOPS, and outstanding I/O, there's simple math between them. They're not magic, they're not independent. You can simply take the spec sheets, do the math, and you will find what latency to expect. There's simple math behind that. Now, again, check out that if you're interested. I did the math here, and the math actually tells me add to 100 outstanding IOs, I'm getting 35 to 50 milliseconds, so vSAN delivered exactly in that range. So everything is actually perfectly expected. There's no problem. The benchmark was simply set up to overload our storage. It tried to do too much at the same time. It got bad latencies. Scale down the workload, and everything will be fine. It will still deliver the same IOPS, but it will deliver it at a better latency. So that concludes the benchmarking section. So let me conclude. We walked through 5 different troubleshooting workflows, 5 different aspects in the lifetime of vSAN. And the first point here is something I actually tried to validate myself doing this presentation, preparing for it. I want to make sure that the vSphere web client is actually enough for the vast majority of situations that you have. And it was enough. For almost anything I wanted to do, the vSphere web client had the high level of information for me to understand what was going on and to get the big picture view and all of that and understand what's happening and drill down. And that's really important for us. And whenever you see that's not the case, tell us, and we want to fix it. We want to make sure that the vSphere web client is that place where you will find that information. However, there will never be a UI that have everything that you ever would want to know. That's not realistic to expect, I think. So we have the tools if you want to drill deeper. And obviously, I showed you how RVC can do that, and I showed you how ESXCLI can do that. You can drill much, much deeper, get the detailed information. So combine the tools to really compose your troubleshooting workflows and procedures. The other thing is combine the different perspectives. vSAN really has the two different angles. It has the angle of the hardware and the wiring, the networking, the physical devices, the rate controls, all of that. You should understand the health of those. And then it has the VMs. The VMs consuming the storage, creating objects, creating components, the health of those, the compliance of those, the performance of those. Look at that aspect as well and combine them to understand the big picture. I hope I was able to show you how to do some of these. Another point I wanted to make is, when putting this together, I actually noticed that I was going back to the same screens again and again and again. And that's actually great. We have relatively few screens in the UI for vSAN. There is not that much about vSAN to consider. That's a good thing. And you can combine these different screens into different workflows very easily, and I hope I was able to show you that. All right, so I have 2 slides here for references. Download the deck. Afterwards, there's a bunch of links. You can take a picture. I will leave it up for a few seconds, but you can also download it. There's lots of blogs, webinars, videos on troubleshooting, and I was only able to scratch the surface today. There's tons and tons of material. Google searches for individual problems will find you tons of information, both on official VMware blogs as well as from the vast community of folks. I don't have it on the slide, but there's a great book about vSAN that came out recently, Essential Virtual SAN is it called. It has great information, so with that, you should be all set. And with that, thank you.